Hey students, in this video I'm going to go over how to formulate absolute value equations from word problems. Okay, so the absolute value equations that we're going to study are going to look like this, which is an absolute value equals a number. So this is the setup behind it. We want to replace this number with whatever is mentioned in the word problem that represents a mean. And that's usually represented when they talk about an average or a net amount of something or a desired outcome or a want. So just read carefully and look for those keywords that will tell you those things. The next part is writing that it equals a number, that number representing the standard deviation. And standard deviation can be rephrased to the amount that it varies by, or what it's tolerant to, or the range of error, margin of error, or the wiggle room, like within this amount. So here are three problems that we're going to go over. The first one is a machinist is directed to make a metal bar with an average length of 7 inches. The metal bars must be within 0.025 inches, otherwise they throw it away. So in class, I just displayed that I had a ruler, and this ruler was 6 inches. So imagine a metal bar that's 7 inches, something like this, being created. And it's not always perfect. Sometimes could be more, could be less than 7 inches, and that's okay as long as it's within this range, within the range of 0.025 more or less. Otherwise, it'll be thrown away. So with that information, we can identify the average of 7 inches. That will represent the mean. And then the keyword of within that many amount of inches, that will be your standard deviation. So the equation will be x minus 7, or absolute value of x minus 7, equals 0.025. So this equation can be solved algebraically to find the unknown value here. And this unknown value will represent what is the maximum or the minimum length that metal bar could be. In class, I pushed you guys to do some logical reasoning before doing the algebraic part so you can see why it makes sense. So minimum meaning smaller. So if you have a metal bar and it could be smaller than the 7 inches, it could be this much less. So we talked about just simply subtracting. Oops, let me clear that. So we have 7 inches, and if we have room for error, it could be just that much. So the smallest length that it could be is 6.975. And then on the other side of that, we could have a little bit longer. So that's when we will add. And then that will be your maximum amount of length for the metal bar. So the biggest it could be 7.025. The smallest it could be 6.975. Now to get those answers, I'll just write inches. To get those answers, we will mathematically do this. We would understand that the absolute value of whatever's in here equals that much. And that amount can be positive or negative. So we can write it as x minus 7 equals 0.025, or x minus 7 equals negative 0.025. Because if we had absolute value, let me just show you that, of 0.025, it is 0.025. But also if we had an absolute value of the negative 0.025, then it will also be 0.025. So what we did right now is just write an equation that equals these two amounts. So we have two equations. Now these two equations are going to be solved, and that's how we end up getting those two answers. For example, x can be solved by adding 7 on both sides. So x equals 0.025 plus 7. And that's how we get this maximum amount. And then if we add 7 as well, that negative 0.025 plus 7, so negative 0.025 plus 7. Oh, it's not typing. And that's how we get 6.975, which is that answer we got there. So this is the algebra level that you need to understand as we move on to the next ones tomorrow. But logical reasoning can also give you these values if you understand that you have something given or set and you have either more or less than that by that amount. Let's try another example. Here is the menu of Gian's favorite restaurant. States that the roasted chicken entree typically contains 480 calories. However, the actual number of calories in the entree can vary by as many as 40 calories. Write and solve an equation to find the minimum and maximum calories. So I'm just going to highlight with yellow my average, my mean, my net amount. So it says typically contains 480 calories. And then I'm going to use with orange the vary by this much. So the equation we will write is absolute value of x minus 480 equals 40. And we can solve this algebraically like we did here, or we can just guess and check, logical reasoning, what will be the minimum amount of calories the entree can have, or the maximum. So minimum meaning if it's right now 480 and it could be less than 480 by 40, we subtract those and then you end up with 440 calories. The maximum amount will be that amount that it needs and then the extra 40 that it could have, so 520. So those two amounts will come out if we solve this algebraically. We will have x minus 480 equals the positive 40 that this could be, or x minus 480 equals the negative 40 that could be. So then we solve it. And to solve for these equations, we would add 480 on both sides. So x equals 520. And then same process, add 480 on both sides. X equals, so again, this is negative 40 plus positive 480. So it ends up subtracting and we are left with 440. All right, let's do one more example. And we have a thermometer is guaranteed to give a temperature no more than 1.2 degrees Fahrenheit than from the actual temperature. If the thermometer reads 28 degrees Fahrenheit, write and solve an equation to find the maximum and minimum. So the keyword that's important here is the actual temperature. It's no more than the actual temperature. So we're going to actually, if you're color coordinating along with me, we're going to highlight the orange, which is standard deviation, because that's how much it could change, no more than that. And then the thermometer reads 28 right now. So the equation would look like this. X minus 28 inside the absolute value, and then it equals 1.2. If, again, we do logical reasoning behind this, the thermometer is reading 28, and it can be no more than 1.2 when it varies. We could add 28 plus 1.2, and that's 29.2. Or we could subtract 28 minus 1.2, which is the 26.8. So those are the maximum that it could vary by. So to do it algebraically, we're going to write x minus 28 equals 1.2. And then that again, x minus 28 equals negative 1.2, because this inside part could be positive or negative. Okay, so then we're going to solve for those. We're going to do the opposite, so add 28. X equals 29.2. And then add 28. X equals 26.8. All right, so those 3 examples should help you practice the scale of formulating absolute value equations from word problems. Hope the video helped you.